So we're going to talk about parallel lines cut by transversal, some more about them. And specifically, we're going to look at some postulates and theorems because we can look at values. Yesterday we looked at identifying corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles. And now we're going to put more numbers to them. And the first one, the corresponding angles, and remember corresponding angles, they're in the same place with regard to the parallel lines and the transversal. So it says if parallel lines are cut by a transversal, then each pair of corresponding angles are equal. So if we look at a specific example over here, angle 5, which is to the left of the transversal and underneath the parallel line, and angle 3 to the left of the transversal and underneath the parallel line. Angle 5 is equal to angle 3. Corresponding angles are equal if we want to keep it similar or simple. But again, you have to have now, which we didn't have to have yesterday, two parallel lines cut by a transversal. And the fact is, you read through these different postulates and theorems, so look at the next one, alternate interior angles. Remember, interior has to be in between the two parallel lines. Alternate means one on one side, one on the other. If parallel lines are cut by a transversal, then each pair of alternate interior angles are going to be equal as well. And if I stick with angle 5 here, which is inside the parallel lines, so here's angle 5 and angle 2, those are the alternate interior angles, then angle 5 equals angle 2. We also talked about alternate exterior angles. And alternate exterior angles, two parallel lines cut by transversal. And each pair of alternate exterior angles are also equal. And we can pick an angle like angle 6 and angle 4 because they're exterior. They're outside of the parallel lines. And we can say that angle 6 equals angle 4. And then finally, same side interior angles. If parallel lines are cut by transversal, then each pair of same side interior angles, they are supplementary. So we have to change it up a little bit. But to show where the same side interior angles are, again, interior has to be on the inside, so we can do something like 8 and 2. And what we can say is, we can say that the measure of angle 8 plus the measure of angle 2 equals 180 degrees. Now eventually, what we're working up to is something called proofs. And theorems are something that we can prove. And what we do when we're looking at these boxes here is we're doing a roundabout proof. So we will be used to it when we get farther along in the year. We're doing proofs. But why are alternate interior angles congruent? And so look above on your paper, because I don't have the picture here on the screen, but we can use corresponding angles to help show us why alternate interior angles are congruent. So I'm going to flip back here, but in the diagram above, line N is parallel to line M, and we want to show that angle 2 is congruent to angle 5. So I'll erase the black marks here, and what we want to show is angle 2 is congruent to angle 5. And so there are those two. when looking at the diagram, we know that angle 2 is congruent. Well, we'll go back here. Angle 2 is congruent. And if we look at what the sentence says, it says it's congruent to something because vertical angles are congruent. So in other words, what's angle 2 congruent to based on vertical angles? Well, if you look at the picture there, it's congruent to angle 3. What we also know that angle 3 is congruent to angle 5 because of some reason. Let's look back at the picture here. Angle 3 is congruent to angle 5. Well, angle 5 is underneath and to the left of the transversal. Angle 3 is underneath the parallel line and to the left of the transversal. And what we call those corresponding angles are congruent. And then what happens here is that angle 2 is congruent to angle 3. And angle 5 is congruent to angle 3. And because they're both congruent to angle 3, because both of those angles are congruent to angle 3, we can say that angle 2 is congruent to angle 5. And eventually, as we go throughout the year, we're going to be doing that without kind of this setup. But let's try one more here. Why are corresponding angles congruent? Well, it's going to be along the same lines. We're still looking at the same picture. It says we can use alternate interior angles to help show us why corresponding angles are congruent. So in the diagram above, line N is parallel to line M. And we want to show that angle 4 is congruent to angle 8. And it's going to be the same reasoning here. When we look at the diagram, we know that angle 4 is congruent to something because the vertical angles are congruent. So if we go back and we look at our picture, well, what is angle 4 congruent to based on vertical angles? Well, angle 4 is congruent to angle 1. See how they're the opposites? So we can say angle 1 because the vertical angles are congruent. We also know that angle 1 is congruent to angle 8. Again, going back and looking at the pictures. Well, angle 1, if we look at the picture, and angle 8, they are in between the parallel lines and on opposite sides. And that's going to be because alternate interior angles are congruent. It's the same reasoning here. Angle 4 is congruent to angle 1. Angle 8 is congruent to angle 1. And because they're both congruent to angle 1, we can say that angle 4 is congruent to angle 8. Now, we've done the theory. So let's work with the numbers, which is better for some people. Example 1. Same basic picture, if not the same picture. It says in the diagram below, lines N and M are parallel, and this time, measure of angle 8 is 116 degrees. And we want to find the measures of all of the rest of the angles. So let's fill in, first of all, 116. And our very first postulate that we had up there in terms of the vocab is the corresponding angles postulate, which says if two angles are cut by a transversal, then corresponding angles are equal. Well, measure of angle 8 and measure of angle 4, then angle 4 is a corresponding angle, which means that it is 116 degrees. But if we look throughout this, not only do we have corresponding, we didn't even talk about it in these definitions, but earlier in our notes, we also talked about vertical angles. Vertical angles are congruent, And angle 6 and angle 8 are vertical, which means that not only is angle 8 and 4 116 degrees, but angle 6, again because of vertical angles, is 116 degrees. Well, angle 6, we've got two parallel lines cut by a transversal, and angle 6 is on the top and to the left of the transversal. So on top and to the left of the transversal, on top of the parallel line and to the left of the transversal is also angle 1. And angle 1 is 116 degrees. And I should have filled in the 116 degrees here on measure of angle 8. Well, we still have 4 more angles to find. The nice thing is once we find one of them, we should be able to figure out the rest. And we can go back and maybe use our linear pair idea. And our linear pair idea says that if we add those two together, we have 180 degrees. We have supplementary angles. So, 7 and 8. You can say 116 plus our angle equals 180, if we need the extra math here. Subtract 116 from both sides. 10 minus 6 is 4, 7 minus 1 is 6. 64 degrees. And now, that's how much angle 7 is. It's 64 degrees. If we take a look at the rest of these, angle 7 is on the top of the parallel line and to the right. Angle 2, which is a corresponding angle, is on the top of the parallel line and to the right. So this is 64 degrees. Angle 7 is vertical to angle 5. And what we know about vertical angles is that they are equal. So angle 5 is 64. And angle 3 is vertical to angle 2. So angle 3 is 64 degrees. And we kept this diagram very simple here, but as we flip our page over, it's the same idea, but we've got a little bit more complex picture. And we just need to be familiar. Can you identify same side interior? Can you identify alternate interior? Can you identify corresponding? Can you identify alternate exterior? Because what we know right now is that measure of angle 3 is 110 degrees. And the measure of angle 12 is 70. So here's 70. Let me fill this in. Measure of angle 12 is 70. And then measure of angle 3 is 110. And then we can get all of the rest. And typically the way I approach these problems is I try to go through and find all of the 110s. And then I go back and try to find all of the 70s. Because I'm looking at corresponding angles and vertical angles, honestly, are the two that I look at the most. For instance, angle 3 is 110. It's on the top of the parallel line and to the left. Angle 11 is on the top of the parallel line and to the left of the transversal. So angle 11 is 110. 110 is vertical, angle 8. So vertical angles are the same. We said that measure of angle 11 is 110, so measure of angle 16 has to be 110 because of vertical angles. Again, the vocabulary and the geometry. If we know the vocabulary, it makes these problems much easier than they would be if we don't know the vocab. If I go back and fill this in, I'm going to change colors here real quick. I'm going to get rid of that 70 and change it to green. But Let me do this here. And maybe you want to mark up your picture as well, like I am. Because what we just said is, we said this is 110. And we said this is 110. And we said that one is 110. So we can figure out the other ones. If you notice, 110 plus 70 is 180. So we can get on this lines L and M being parallel in the transversal 4, or T, we can get the rest of these on this side, because 70 is vertical to angle 15. And again, vertical angles are equal. And now that we know that, we can look at the top of the parallel line, and to the right is 70, the only one I have marked on here. So the top of the parallel line and to the right for angle 4, if I can find it, is also 70. So here's 70. Angle 4 is vertical to angle 7. Opposite angles there for the vertical. So here is 70. And I didn't write down the 15, but there's that. So now we have all of that. But we still have 1, 2, 5, 6, 9, 10, 13, 14. Go back and look at the corresponding. If you need to, twist your paper around. If that makes more sense to you, to twist the paper around to come up with the corresponding, maybe that's helpful for you. Because what I see here, if I start with these 70s, is 70 is on the top and to the right, compared to parallel lines S and T, with the transversal then being L. So since angle 4 is 70, angle 2 is also 70. See how they're in the same place? So angle 2 is 70 degrees. Angle 2 is vertical to angle 5. So it is 70 degrees. Angle 2 is on the top and to the right of the transversal. So angle 10 is on the top and to the right of the transversal. And angle 10 is vertical to angle 13, which means that that is 70 degrees. And if I fill those in, we can finish. The good news is, our answers in this particular case, because we're looking at corresponding angles and we're looking at vertical angles, your answers are either going to be 70 or they're going to be 110. So what we know, 110 here on, I can't see which value it is, I think 3. 110 on angle 3, which is on the top and to the left of the transversal. So angle 1 is on top and to the left, so it's going to be 110. Angle 1 is vertical to angle 6, so it's going to be 110. Angle 6 is underneath and to the right, so angle 14 is underneath and to the right. And angle 14 is vertical to angle 9, which gives us the 110. So as we get close to finishing, now, the following sets of lines are parallel. Find the value of x. What might be even more important here is, can you identify what kind of angle we're working with? If we take a quick look at this picture here, the type of angles that we're working with in this particular one are alternate interior angles. And on alternate interior angles, if we look back to our theorems and postulates, what it says is, it says if parallel lines are cut by a transversal, then each pair of alternate interior angles are equal. So that means, when we look at this problem here, we can take 2x and we can set it equal to 3x minus 26. Solve it the way your Algebra 1 teacher taught you. I'm going to move the letter to the left. So negative 1x equals negative 26. And then we're going to divide both sides by negative 1. So x equals positive 26. Letter B. Again, can we identify the different types of angles? Well, on this particular diagram, what we've got two parallel lines cut by a transversal, and then we have same side interior angles. And if we look back to the front of our paper, what it says about same side interior angles is that our angles are going to be supplementary. They're going to add to be 180 degrees. So what we can say is we can say 4x plus 3 plus 7x plus 1 is 180. Remember, when we solve these equations, we need to add like terms. 4x plus 7x is 11x. 3 plus 1 is 4. And that equals 180. If we subtract 4 from both sides, we get 11x equals 176. And then we want to divide both sides by 11. And you can use decimals, you can use a calculator here. 176 divided by 11, 16. And finally, if you can identify the right types of angles, then that makes all the difference in terms of answering these questions here. It says in the following problem, really below, each set of lines are parallel. Find the value of the missing variables. So we've got a couple of things. But the first thing that I noticed on this particular problem is that 2x minus 10 is underneath and to the left. X plus 15 is underneath and to the left. Those are corresponding angles, and we can set those equal. 2x minus 10 equals x plus 15. Again, solve it the way your Algebra 1 teacher taught you. Let's subtract x from both sides. We get x minus 10 is 15. And then we need to move the 10 over to the other side. So we're going to add 10 to both sides. We get x equals 25. But what we also have to figure out is, what does y equal? And the other type of angles that we have in here, I'm particularly looking at 2x minus 10 and 4 times the quantity of y minus 25. Those are alternate exterior angles. And again, it's easier for you to flip over your paper and look at the alternate exterior angle rule, but alternate exterior angles says if two parallel lines are cut by a transversal, then each pair of alternate exterior angles are equal. So we can set those equal to one another. So we've got 2x minus 10 equals 4 times y minus 25. And the first thing that we want to look at here, or maybe deal with, is taking that value of 25 that we found for our x and putting it back into that x. So this is going to be 2 times 25 minus 10 equals 4 times y minus 25. Well, 2 times 25 is 50 minus 10. And over here on the other side, let's distribute right now. 4 times y, 4 times 25, gives us 4y minus 100. And 50 minus 10 is 40. Equals 4y minus 100. Going to move the 100 over to the left. And we end up with 140. 4 times y. To finish, we'll divide both sides by 4. And 140 divided by 4 is 35.